What happens when you learn a new piece of information? Does it change your view of the world? In probability, new information doesn't just change your perspective, it completely changes the math. This is called conditional probability. Imagine drawing a single card from a standard deck. The probability of drawing a king is 4 out of 52. About 7.6%. But wait. What if I peek at the card and tell you it is definitely a face card? The universe of possibilities just shrank. Since you know it's a face card, the sample space isn't 52 anymore. It is only 12. The probability of it being a king is now 4 out of 12. 33%. We write this with a vertical line, the probability of A, given B. This brings us to one of the most powerful equations in all of human history, Bayes' theorem. Named after an 18th century minister, it tells us how to properly update our beliefs when we encounter new evidence. Let's look at the ultimate brainbreaker. This is the false positive paradox. Imagine a rare disease affects exactly 1% of the population. A lab creates a test for it that is 90% accurate. You take the test, and it comes back positive. Panic sets in. What are the actual odds you are sick? Most people think the answer is 90%. But let's look at a population of 1,000 people. Statistically, only 10 of them actually have the disease. Because the test is 90% accurate, it correctly flags 9 of those sick people. But what about the 990 healthy people? A 90% accuracy means a 10% error rate. The test will falsely diagnose 99 healthy people as sick. So, out of 108 total positive tests, only 9 people are actually ill. Your chance of being sick is barely 8.3%. This is the magic of Bayes' theorem. Your intuition screams 90%, but the math proves it is less than 10. This exact formula is how spam filters, self-driving cars, and artificial intelligence make decisions. Next time, we will look at the shape of chaos, the normal distribution.